Hello, Professor. This is my final project presentation. My name is Bochuan Tao, and my project contains two parts. The first part is breast cancer prediction, and the second part is a follow-up on the third homework. Because you said my first part is a little bit easy for a project, so I decided to do a follow-up on the third homework. So let's dive into the first part. The data contains 33 columns for every instance. There are total 569 instances and no missing data, which is quite good. And there are 357 benign and 212 malignant instances, so the data is not too skewed. The data type is float. Between the 30 features, some of the features are highly correlated, so we need to do some feature selection. I used 6 ways to say how feature selections can influence the prediction. So as for the original data, if we do not perform any feature selection, the accuracy is 0.98, which is very high. And if we manually select 11 irrelevant features based on correlation matrix, we get accuracy of 0.95. So the 19 features that we drop do not influence the prediction rate too much. And if we use univariate feature selection, we select 5 features based on this method, and the accuracy is 0.88. And for the fourth method, the recursive feature elimination, we also extract 5 features from this method, and the accuracy is 0.93. We want to know how many features work best for the prediction. So we do a grand search. If we do a grand search on the features that we chose before, the 11 features that we chose, we get 6 features out of those, and we get accuracy of 0.95. And if we do a grand search based on the original data, we can get 0.98 accuracy. So many of the features do not influence the prediction much. So let's get to the prediction on the test set. We use the features from the 5th method and the 6th method. I used 2 classification methods. For the 5th method, the accuracy is 0.96 and 0.95 respectively. And for the 6th method, the accuracy is 0.95, 98, and 0.96 respectively. So they are quite high. So as we can see, many of the features do not influence the prediction. We can say it from the PCA feature extraction. As we can see, the number of components, when the number of components is larger than 5, the variance do not change too much. So the most important features are, the number of most important features are around 5, 6, something like that. So the conclusions are, all the 30 features can be mostly represented by 6 most important features, and for this case, logistic regression is slightly better than random forest. So let's move on to the second part, the cipher-10 based on VGG. The reference is very deep convolutional networks for large-scale image recognition. Based on this thesis, I designed a network containing 19 layers, and the back size is 32, and I iterated 140,000 times. The final accuracy on the test set is 0.841, which is better than NXNet, and for the homework 3, I only get 70% accuracy. So this concludes my presentation. Thank you, Professor. Thank you for your dedicated teaching. I hope you have a great day.